So now let's talk about actually finding an inverse function, right? So if we get a function f, how do we know what its inverse function is once we verify that it is one-to-one and it does have an inverse? Or maybe before that, we might want to know if we're given two functions, how can we verify whether or not they're inverses of each other? Okay, so two steps. One, verifying if functions are inverses of each other. And two, given a function, actually finding the inverse function. So let's start with the definition of an inverse function. So we say f of x and f inverse of x are inverses of each other if f of f inverse of x equals x. So in other words, we compose them. We compose f with its inverse function. It should bring us back to the identity function, which in function composition would be x. But because this is not commutative, right? In other words, the order that the composition matters, we also have to make sure it works the other way. So, and f inverse of f of x equals x. Okay, so we have to check both of these. So let's do just a couple of examples first to get started. Let's say we have f of x equals x plus 3 and g of x equals x minus 3. Okay, we're not going to call it f inverse of x right off the bat, implying that it's an inverse function if we don't know that they're inverses, right? So maybe we'll call it g, like we did here. So let's go ahead and do f of g of x and see what we get. So f is x plus 3, so we're doing f of x minus 3 because that's what g is. So we're going to plug this in for x. We're going to x minus 3 plus 3 equals x. Okay, so one of these statements is verified. G of f of x, then, it's going to be g of x plus 3, which equals x plus 3 minus 3, which equals x. Okay, so put some check marks here. So we say these are inverses of each other. Okay, so f and g are inverses of each other, inverse functions. Okay, let's try another one. F of x equals x plus 3 divided by 5. G of x equals 5x minus 3. Okay. So it seems plausible that these would be inverses of each other, right? If you notice up here on this one, you can kind of tell they're inverses of each other because this one's adding 3, this one's subtracting 3. So if they're doing opposite things, we expect them to be inverses. Here, same idea, right? We are adding 3 and we're dividing by 5. Here we're multiplying by 5 and we're subtracting 3. So maybe again we would expect them to be inverses. If we do f of g of x, we're going to do f of 5x minus 3, which is going to be 5x minus 3 plus 3 divided by 5. These cancel. We have 5x over 5, which is x. Okay, so we're good in one direction. G of f of x. Okay, so this is g of x plus 3 over 5. Okay, so we have 5 times x plus 3 over 5 minus 3. Okay, 5 divided by 5. Those cancel. We have x plus 3 minus 3 equals x. So we're good in both directions here. So we verify that these are indeed inverses of each other. Let's look at kind of a related problem here. If we had f of x equals 5, sorry, what did I have? X minus 3 over 5. And, well, this is what we had before, right? So what if we, or x plus 3, what if we change this to x plus 3 and just divide the x by 5? Okay. And then g of x equals 5x minus 3. So this is another one where you might look at it and you might think, okay, it's plausible that these are inverses of each other. But we already know what the inverse function of g is, right? The inverse function of g is x plus 3 over 5. And this inverse function is unique, so it can't have more than one. So what is the issue here? Like, even though it looks like these are, they're inverses in terms of like the operations, right? Like, one's doing division of 5, one's doing multiplication of 5, one's adding 3, one's subtracting 3. So what's the issue? And, you know, sure enough, if we compose these, we should see that they aren't inverses of each other. So we're going to get 5x minus 3 over 5 plus 3. So this is going to be 5x over 5, which is x, minus 3 over 5 plus 3. So, you know, we don't need to actually do the addition here. We can just already see that this isn't going to be x, so these aren't inverses of each other. So the problem kind of lies in the order of operations here, right? This one, f is dividing by 5 and then adding 3. G is multiplying by 5 and then subtracting 3. For them to be inverses of each other, you would also have to invert the order of operations between the two. Okay. In order for it to completely undo what the other one does. So we had that in the first one. Here we added 3 and then divided by 5. Here we multiplied by 5 and then subtracted 3. So different order with the addition. You know, in F the addition is first. In G it's last. Subtraction in that case, but they're on the same step, right? Here the division by 5 is last. Here the multiplication by 5 is first. So it also inverts the order. So just subtle things like that that can kind of trip us up. This is why we need to verify that things are indeed inverses. Okay. So one interesting case that I mentioned before is f of x equals 1 over x. I mentioned that it's its own inverse, so let's show that it's its own inverse. Okay. So f of x, this is going to be 1 over x. Okay. So we got to be comfortable with our fraction properties here. 1 divided by 1 over x. This is the same thing as 1 times x over 1, right? We think of this as same change flip, right? In other words, multiply by the reciprocal. So we get x. F of x equals x. We don't need to do it in both directions here because it's the same thing, right? In this case, because these are the same functions. So we can confirm here that f of x equals 1 over x is its own inverse.